Hi guys, so today we're doing the flip session on writing equations of parallel and perpendicular lines. In our first exploration, we're going to use the following three equations below: y equals 2x plus 6, y equals 2x minus 6, and y equals 2x plus 4. And for each of those equations, we're going to first find the slope, then find the y-intercept, and then we're going to graph all three equations. So, you guys should recall that y equals mx plus b is an equation of the line in slope-intercept form, where our m is our slope and our b is the y-intercept. So, we're going to look at this first equation right here. Y equals 2x plus 6. It's already in mx plus b form, so this is easy for us. Our slope is 2, and our y-intercept, our b term, is going to be 6. Now I want you to pause the video and do the same thing for the other two equations. Okay, so hopefully you got your m, or your slope, is going to be 2, and your y-intercept is going to be negative 6. And for that last equation, 2x plus 4, again, our m term, which is our slope, is 2, and our y-intercept is 4. So now we're going to go ahead and graph the following three equations on our coordinate plane below. Okay, so for this first equation right here, y equals 2x plus 6. My y-intercept is 6, so I'm going to start at 6 on my y-axis. And the slope tells me it's a rise over run, so I'm going to go up 2 to the right 1. Since I cannot continue on going up that way, I'm going to start back here and go the opposite, down 2 over 1. Down 2 over 1. Down 2 over 1. Down 2 over 1. And then I am going to connect my points to make my line. Okay, so like before with the red and the green equations, finding the slope and the y-intercept, I want you to pause the video and I encourage you to plot those 2 points, those 2 lines yourself. Okay, so hopefully your 2 other equations are graphed like this. The red one, we were starting at negative 6, up 2 over 1, up 2 over 1, up 2 over 1, and so forth. And for my green equation, y equals 2x plus 4, we're starting at 2, going up 2 over 1, up 2 over 1, then down to left 1, down to left 1, down to left 1, and so forth. So, what I want you to do now is look at our work for these 3 equations and the graph of the 3 equations. And I want you to pause the video and come up with answers to 1, 2, and 3. 1 being, what observations can you make about these 3 lines? What do you notice about the slope, which is your m term of each line? And then to draw a conclusion based on this activity. So please pause the video and answer those 3 questions and then check in for your answers. Some possible answers that you could have gotten for question number 1 is, the lines do not intersect, they seem to be parallel. What do you notice about the slope of each of the lines? So the slope was your m term, so we're going to go back and look at our m equals 2, m equals 2, m equals 2. What do you notice about those slopes of each line? They're the same, or that they are equal. And to draw a conclusion based on this activity, when equations have the same slope and different y-intercepts, the lines will be parallel. Okay, so for exploration number 2, we're going to use the following 2 equations below. Y equals 3 halves x minus 4, and y equals negative 2/3 x minus 1. And for each, we're going to find the slope, the y-intercept, and then graph the two. So again, our two equations are already in y equals mx plus b form. So we could go right ahead and state our slope is 3 over 2. And our b, our y-intercept, is going to be negative 4. So like before, I encourage you to pause the video and try it on your own for the second equation. So we have a slope of negative 2 over 3 and a y-intercept of negative 1. So now we're going to go ahead down and graph our two equations. Starting with the first one, we have a y-intercept of negative 4, and we are going up 3, 1, 2, 3, to the right 2, 1, 2. Up 3, 1, 2, 3, to the right 2, 1, 2. Up 3, 1, 2, 3, to the right 2. And we are going to connect those with a line. Now I want you to pause the video and do the same thing for the second equation. So after you tried it, your line for the blue should look like this over here. We're starting at negative 1. We are going down 2 over 3. Down 2 over 3. Again, our slope is negative 2/3. So our equation, when it's graphed, should have a negative slope going downwards. When you read from left to right, your equation should be going down because it's a negative slope. All right, so now we're going to answer those questions, number 1, 2, 3, and 4. 1 being, what is the measure of the angle created when these two lines intersected? What observations did you make about those lines? Can you find any connections between the slopes of these two lines? If so, explain, and then draw a conclusion based on this activity. At this time, I'd like you to pause the video and answer those 4 questions. So for question number 1, what is the measure of the angle created? 90 degrees. What observations did you make about the lines? That they are perpendicular, because remember, perpendicular lines form right angles. What connections were made between the slopes of those two lines? So we're going to go back up here and look at our slopes, 3 over 2 and negative 2 over 3. You should have said they have opposite signs and they are reciprocals. Remember, the reciprocal of 3 over 2 is 2 over 3. The reciprocal of 4 over 1 is 1 over 4. The numerator and the denominator are switched. Draw a conclusion based on this activity that perpendicular lines have negative reciprocal slopes. Parallel lines have the same slope. If it has the same y-intercept, the line is just going to sit on top of the original. Perpendicular lines have negative reciprocal slopes, and perpendicular lines are also referred to as normal lines. Okay, we're going to go through exercise 1. Given the equation y equals 2x plus 6, we want to write an equation that is parallel to the given line and to write an equation that is perpendicular to the given line. So we're going to start with the first one. If we see that word parallel, we should know that it is the same slope. Our slope is here. So an equation of that line, we use that same slope, which is 2. So y equals 2x. And we are going to pick any value for our y-intercept. I am just going to write 4, but remember, your y-intercept, this value right here, could be any value. And then write an equation that is perpendicular to the given line. Perpendicularly means that our slope is going to be the negative reciprocal. So if our slope is 2, to figure out the negative reciprocal of that, you could really say that's 2 over 1. My opposite sign from positive is negative. And if 1 is on the denominator, it becomes the numerator, and the numerator becomes my denominator. So my slope for a perpendicular line is negative 1/2. So an equation that is perpendicular to my original would be y equals negative 1/2 x, and any y-intercept that we want, I'll just put 3. Negative 1/2 x plus 3. Again, your y-intercept could be any number that you want. Example 2. Given the equation y equals 2/3 x minus 5, we want to figure out what is the slope of a line that is parallel to that line above. So here we're just looking for a slope. So m is equal to the same slope that we see there. So our slope of a parallel line would be negative 2/3. Then for part B, it's saying what is the slope of a line that is perpendicular? Again, perpendicular lines have negative reciprocal slopes. So my slope of a perpendicular line would be the opposite sign of negative, which is a positive, and then the 2 and the 3 are flipped and switched. So now our slope of a perpendicular line would be 3 over 2. Exercise 3. Given the equation 2y minus 5x equals 10, we want to write an equation that is parallel and write an equation that is perpendicular. You should notice that right here, 2y minus 5x equals 10 is not in y equals mx plus b form. So we are going to rearrange it so that it is. We want to isolate that 2y, so we need to do the inverse of negative, which is a positive. So we're adding 5x to both sides. That cancels out. We have 2y equals 5x over 10. 5x plus 10, I'm sorry. So if we want to isolate our variable y, right here, we need to get rid of that 2. We need to do the inverse of multiplication, which is division. We need to divide on both sides. Whatever we do to one side, we must do to the other. So those 2's cancel out, and my equation is y equals 5 over 2x plus 10 over 2, which simplifies to 5. And here, if we want it to be parallel, we know parallel has the same slope. So y equals the same slope over here, 5 over 2x. And again, my y-intercept can be any number, so plus 7. And here, write an equation of the line that is perpendicular. Perpendicular, we have negative reciprocal slopes. So 5 over 2 for a perpendicular slope, we have the opposite sign. So the opposite of positive is negative. Reciprocal, the 2 and the 5 switch places. The 2 is now in the numerator and the 5 is in the denominator. So the equation of this line could be y equals negative 2 over 5x. And again, my y-intercept could be any number, plus 4, I'll say. All right. So there are a few questions that I would like for you to do in addition to copying the notes that you just did. I will see you tomorrow.